What's up, young mathematicians? Thank you for stopping by here at Talk to Pi. I am Caesar the Tutor, and today we're going to be graphing a quadratic from standard form. There are many methods for graphing a quadratic function, and today we will be taking an overview at all the ways to graph it. But we will be looking at an example of how to graph one if you're given one in standard form. So, without further delay, let's get started. As we said before, when you graph a quadratic, you're going to end up with a parabola. And there are 4 different ways to graph a parabola. Number 1 is by using a table. You can input values for x and get values for y and put it all in a nice graph, and you'll end up with a graph of a parabola. However, that is a little time consuming. The second way you can do it is by using certain characteristics from the general equation itself. The third way is by vertex form. And the fourth way is by using the focus directrix, which we'll go over much later in the course. Before we begin graphing quadratics, let's take a look at a few characteristics of the graph of a quadratic. First, the shape is a parabola. And a parabola is this U-shaped thing. So it's a U shape. Now it can be facing up, it could be facing down. For purposes of this course, we're only going to be looking at vertical parabolas. We're not going to be looking at horizontal parabolas, which do exist. This is the graph of x equals y squared. And as we can see, it's not a function, so we're not going to even discuss it for today. But let's take a look at these two and see what we can pull out of those two graphs. Now, first, notice the direction, right? This one's facing up, this one's facing down. So one of the things we have to look out for is direction. Number 2, well, this one on this side does not hit the x-axis. It hits the y-axis, but it does not hit the x-axis, and it will never hit the x-axis because it's always going up in that direction. This one, on the other hand, does hit the x-axis. Now, when a parabola hits the x-axis, or any graph hits the x-axis, it's called the x-intercept. We like to call it, for the solutions of a parabola or a quadratic, we call them the roots, or the solutions, or the zeros. So we're just going to say we also might want to look at the roots. Other points of interest? Well, since we looked at the x-intercept, we might as well look at the y-intercept as well. And so that's another one that's going to become important, the y-intercept. And finally, for now at least, we have this sort of point which this parabola does not go above. This point right here is this parabola's maximum value. Now, on the other hand, in this case, we have a value where the parabola does not go under. So that is going to be the minimum value of the parabola. Now, of course, this is simply the vertex. We call this the vertex of the parabola. It is the lowest or the highest point in a parabola. So I'm just going to put it here, the vertex. Now, the vertex is composed of 2 things. Okay? Of course, we know it's going to have an x value and a y value. But the x value of the vertex is actually what we call the axis of symmetry. So axis of symmetry. And the y value is simply the max or the min. So I'm just going to put it here, max / min. And that's what we have. I mean, that's all the points that you would like to have if you want to graph a quadratic. Later on, we're going to see how to find those values to make it easier for us to graph those points and to find the graphs of a parabola. Now, let's take a look at other characteristics while we're here. We can see from this one that it's going to keep going forever in that direction, and it's going to be going forever in that direction. So my x values are everything. So my domain is all real numbers. Domain is R. And we can see that the range starts here. It doesn't go below this point. So it starts at this point and goes up. So the range is not all real numbers. The range starts at the minimum value in this case. On the other hand, for this upward parabola, we have that the domain is also all real numbers. So domain in this case is all real numbers. And the range in this case is also limited because this parabola only exists from that point down. So the range is not going to be all real numbers. And that's going to be helpful later on. Now, as we talked about it, polynomials are functions, and now we can see that this specific polynomial, which happens to be a quadratic polynomial, is indeed a function from these graphs. Now let's take a look at an example to see how we can find each of these things from the standard form. So number one, direction. To find a direction, all we have to do is look at A. If A is positive, the direction is up. If A is negative, the direction is down. A would be the coefficient of the x squared term. And in this case, the coefficient of the x squared is simply 1, so the direction is up. So I'm just going to put it up here, up. I recommend that you keep a little chart on the side, just so that you can have all your stuff organized, and then at the end we can just graph it. The roots. Now we know that to find the roots, we need to take this equation and set it equal to 0, because that's what the roots mean. When does this equal 0? When does it hit the x-axis? So let's see. X squared plus 6x plus 8 equals 0. We're going to use the factoring here. So I'm just going to take my two parentheses and set them equal to 0. And now I need two numbers that multiply to positive 8 and that add up to positive 6. And that's going to be 2 and 4. So x plus 2, x plus 4. And from here we can see that our roots are going to be x equals negative 2, comma, negative 4. So to write them as points, I'm going to simply write them up here as my roots are negative 2, comma, 0, and negative 4, comma, 0. So those are my roots of my equation. The y-intercept. To find the y-intercept, I just need to ask the question, what is the value of this function when x equals 0? So all I have to do is plug in 0 or solve g of 0. So that's going to be my y-intercept. And in this case, g of 0 is going to be equal to 0 squared plus 6 times 0 plus 8. 0, 0, 8. So that's just 8. My y-intercept is 8. So I'm going to put it as a point 0, comma 8 because it is a point. To find the vertex, now we need two things. We need the axis of symmetry, and we either need the maximum or the minimum value. In this case, well, we know the direction is up. So somehow this parabola is going to be facing that way. And because the direction is up, it means that it has a minimum value. So whatever we find is going to be our minimum value. But how do we find all that? Well, first, we need to find the axis of symmetry, because that would be our x component of our vertex. And our axis of symmetry is found using this formula. So I'm going to put it right here, axis of symmetry. Wow, I can't spell. Okay, axis of symmetry. And the formula is simply, it's going to be an x value, and it's going to be x equals negative b over 2a. So, the axis of symmetry simply takes the value of b, in this case is 6, and the value of a, which in this case is 1, plugs them in, and there we go. So x equals negative 6 over 2 times 1, which gives us negative 6 over 2, which gives us negative 3. So that means that our vertex has an x value of negative 3. So we're halfway there. We also know that if we draw a vertical line through negative 3, when we graph it, we would be able to see the symmetry in there. And finally, we just need to find that y value. And to find that y value, all we need to do is plug in negative 3 into our quadratic and find the value of g of negative 3. So what we're doing is y equals g of negative 3. So that means let's plug in the x value of negative 3 in here and see which y value it corresponds to. So that's going to be g of negative 3, which is equal to negative 3 squared plus 6 times negative 3 plus 8. And after we do all the math, negative 3 squared is positive 9. Negative 3 times 6 is negative 18, so this is going to be plus negative 18. And finally, plus 8. And here we get negative 9 plus 8 is negative 1. So we end up with a y value of negative 1. Our g of negative 3 or our y value is negative 1. That means that this y value corresponds to the y value of our vertex. So in this case, our axis of symmetry is negative 3. And our minimum or maximum value, which in this case we know since it's facing up, it's going to be a minimum value. So we can say min at y or f of negative 3 equals negative 1. And we'll write it all out right now. Now, armed with everything we have, the direction, our roots, our y-intercept, our vertex, we're going to go ahead and produce a sketch of a graph here. So, direction's up, makes sense. Roots, negative 2, 0, and negative 4, 0. So I'm just going to go ahead and go 1, 2, 3, 4. And this is my negative 2, this is my negative 2, 0, not this one. And this is my negative 4, 0. My y-intercept is at 0, 8. Now, do I need to count 8 steps? No, I'm only going to graph one graph here. So I can just put a very arbitrary mark there and say this is 8. And I just need to make sure that when I draw my graph, it crosses that point. Vertex at negative 3, negative 1. So now we're going to go negative 1, negative 2, negative 3, negative 1. And here's our vertex. And now, in most homework problems, they ask you to provide 5 points. 5. So here we have 4. We have the roots, the vertex, and this point that's the y-intercept. But see, we know a few things here. We know that we have an axis of symmetry at negative 3. That means that everything that's on the right of that green line is also on the left of that green line. So we know that the x value of this is negative 3. That means that 3 units away and 9 units up, we have another point, right? 1, 2, 3 units away, and then 1 unit, and then that's at 8, so that's 9. So 3, 9. So then I can also do the same thing here on the other side. I can go 3 units away from this one, and then 9 up, and put my other point right there. And I know for a fact, because of symmetry, that there's supposed to be a point at 1, 2, 3 units away, and then 9 units up. So there's supposed to be another point here. And I can actually tell you what that point is. Well, because if this is negative 3, and I just went 3 in that direction, that's going to be negative 6. And I know it's at the same height as 8. So that's negative 6, comma, 8. And so now we have the graph of our parabola. And one thing you always want to make sure, some teachers are very strict about this, is you want to make sure that these are going out. So you don't want to make them so that they come back in on themselves, because this kind of means that it's going back on itself. And I know it seems kind of weird that they're like, oh, why are you being so strict about that? But some teachers just like to make sure that you understand that part. There will be other functions later that are not going to have that characteristic, and you just need to make sure that you understand that part. Now we also know from here that domain and range is all real numbers. Domain is all real numbers, but our range, so now that's usually a common question. What is a domain? And of course, we don't even need to graph it to know that if it's a quadratic, it's a polynomial. And if it's a polynomial, the domain is all real numbers. So we can actually just say this is negative infinity, comma, infinity. Sometimes we put the positive just so that we can differentiate between both. But the range here is what matters, because this one starts at -3. Now I wrote it over here as the minimum occurs at f of -3. That means when you plug in the value of -3, the x value of -3, we are going to get a value of -1. And that's pretty much our range as well. Our range starts at -1 and continues all the way up to positive infinity. So we can just say range is going to be -3 to positive infinity. Now, oh, no, it's -1. And not only is it -1, it includes -1. So bracket -1 and all the way to infinity. So just to recap everything we just went over, when given a quadratic in standard form, ax squared plus bx plus c, and you are asked to graph it, we need to find 4 things. Number 1, the direction. Is it going up or is it facing down? If a is positive, it's facing up. If a is negative, it is facing down. Number 2, the roots, the zeros. How many does it have? 0, 1, or 2? Next, the y-intercept. And when given in this form, the y-intercept is simply c. So you just take it from there, and the y-intercept is going to be 0, comma, c. And finally, we get to the vertex. Now, the vertex is composed of 2 things, the x value and the y value. The x value is also known as the axis of symmetry. The axis of symmetry, we find it by using the formula -b over 2a, which we simply take b and a from our standard form. Once we find our axis of symmetry, once we find our x value, we then plug it back into our formula, into our function, to find the y value. And that's going to tell us whether it's going to be a maximum or a minimum. We already know it's just going to tell us the value of the maximum or the minimum. That is all for today's lesson. Thank you for stopping by. If you like the video, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to put them in the comments below. Thank you.